Hi, everyone. I'm going to be presenting my final project for CS 221 fall 2025. Um, this project is about Java exception embeddings and severity analysis. It's an automated severity classification system using developed using NLP and PyTorch. I'm the only member of this project, and this is the GitHub URL. Um, Java exceptions vary in severity. They are recoverable versus very critical. Manual log triage is time consuming and error prone. So the goal of this project is to automate the severity classification. Dataset is about 1,000 samples, mostly synthetic, split about 80-10-10. Fields, exception name, message, optional stack trace, label. Pre-processing, lowercasing, tokenize, deduplication, and we're using word2vec with 100 dimensional vectors. And the class is severe, count is around 42%, and non-severe around 58%. The approach we used versus the baseline, which is rule-based, is essentially hard-coded if statement, if else statement with error, exception name, with severe and non-severe. It is very fast, interpretable, no training required. Accuracy around 79.4%. And the other comparison model that we will be using for this project is neural network, word2vec, 100-dimensional, 3-layer feed-forward neural network. Architecture is 100, 6432, ReLU, and 2 softmax. Accuracy is 100%. Key findings: accuracy improved from the baseline, about 20%, 20.6%. F1 score improved 32.49 points. Precision is 1. And baseline recall from 0.5 to neural network is 1.0. Example of inference flow is, one of the inputs just showing here out of memory, Java heap space, tokenize, word2vec embedding, neural network paths, probabilities, predicted label severe. Conclusion, embeddings and neural network outperform rule-based. Message content adds valuable signals, potential for real-time log triage. Future work, we can try to use sentence BART for richer embeddings, expand data set, handle class imbalance, integrate into monitoring tools, better, real time. I'll just go over the Git repo very quickly. What are the files that are included? There are some source files. There's this, since I use mostly synthetic dataset, generate dataset, pre-processing, utilities, word2vec training, embeddings, PY, baseline, PY model, train, inference. It's a neural network base model, 80-10-10 split for the data, and evaluation metrics, precision, accuracy, and F1 score. So if I go over the source, just looks like this. These are some of the files. These are the models. And if I go back to the README again, it will give instructions how to run it after downloading the source code. Create a virtual environment, and then do all these instructions, and you can run the process. For this presentation, I will run the run pipeline, which essentially will run all the steps. So if I run it, probably first just clear the screen. Command. So we'll go over step by step all of the Python files and what are the actions of those Python files, and then we will go over the output. Let's train the model. So if you scroll up, so this is where I started. So it first generates the synthetic data set, train word-to-vec embeddings, and it runs the baseline classifier. Essentially, this is the result. Train the neural network. It's using CPU instead of CUDA. Displaying the data set. Train the model. Accuracy 100%. And then train comparison report between the rule-based and neural network. You can see the increase in accuracy. It's 79% versus 100%. So that's pretty much it. And we did generate some reports here. Could find some results. Comparison. This is the text file we just went over. It generates training history where we can see that the training loss is going down. And the value accuracy starts to converge around 1. That's it. Thank you for listening in.